Hello students, welcome to Fly with Physics. In this video we will be discussing about the constraint system, and the basic topic that we will be discussing today is pulley constraints. Okay, first of all I will be discussing you about the basic meaning of constraints. Constraints meaning that you have you don't have a freedom, means you have some rules applied to your motion. So for every object there is some if there is some rules applied on that you say object for its motion, then these rules are known as constraints. For example, a car is moving in a straight line only, it doesn't move that place or that place, so it is the constraint for the car that it is to be it should have to be moved on that direction. Okay, for example this direction is also fixed, and for example their you say their axis is also fixed, that it will be moving on just you say in x axis only. So this is the constraint, these are the rules for this car, and this is known as the constraint. Okay, so this is all about the constraints. And if there is no constraint for any body, then the body will be freely moving at in the 3D space, you say. Okay, but now today our topic is to study the constraints, so we will be considering some you say some objects under the constrained motion, means under some rules, their motion will be under some rules, and we will be formulating for their you say their speed, their distance that they have to travel, their acceleration and all that. Now we will see first of all, then you will get more clear for about the constrained motion. So here in the first case, you say in the very first basic, we will just starting with the Atwood machine. What do you mean by Atwood machine? First of all, I will be describing here. Atwood machine is the it is just the assembly of this system, in which there is one pulley. This is known as pulley. Okay, and this is a pulley, and it is frictionless. First of all, there will be no friction for this pulley, means the string is just experiences no friction against this pulley. Okay, so and this one is string here, and the speciality of this string is that it is massless, and it is inextensible. Means that it is not like just elastic, it is not elastic, it is non-elastic, means there its length is not changing when you stretch it or you say compress it, no issue. Okay, so their length is not changing, means this is known as their inextensible nature. And massless means their mass is such that negligible that you cannot include in your numerical part. Okay, so this is massless string and inextensible. These are the masses. This is object 1, this is object 2, this is the mass of object m1, and this is the mass of object m2. Although if in this case the acceleration due to gravity is acting on these masses in downward direction, so at which force it is equal to mg, है ना, for that case, and for that case this is m1g, for f1 for this, f2 for this. Now when you say, when for example m2 is heavier than m1, then m2 moves downward and m1 moves upward. Okay, so when m2 moves downward and m1 moves upward, the tension in the string is applied here. The tension means a force. This is not like वो वाला tension जो हम लेते हैं. This one is tension means the force. Tension is just meaning the force. The force is acting on a string here, because string has also you say the atoms and molecules. So atoms and molecules experiences the force. Okay, so one thing you have to just two things you have to just remind in your mind, that for the next few classes you will follow these two you say points at all. Okay, now first point is the tension. If there is a tension in the string, means there is a force in the string, so it is constant. First of all, if we are taking that force tension is T, then it remains constant for the length of the string. and the string must be massless and string must be frictionless. Okay. Yes. Okay, now the direction of the t means the direction of this force acting in a string. It must be away from the contact points and the tied ends. Means for example, this is the contact point. This is the first contact point here, where string is contacted with this mass, and this is the second contact point, and this one is also a tie. This was also contact with the pulley. This one is also contact with the pulley. So at that points, the tension means that force is acting away. Okay. Similarly, at that point, the tension is acting away. At that point, tension is acting away. At that point, tension is acting away, and it is constant here. Okay, and it is constant here. So this thing you have to know, that there is a tension in the string and it is constant first of all, and the second one is the direction of t acts always at the away from the contact point, away from the contact points. Okay. So after completing this, you will be just moving on the very basic concept of these constraints. We will be finding the case where for example, this m2, this is m1, and this m2 is moving downward, and this m1 is moving upward. Okay, if m2 is moving downward, means if m2 is heavier than m1, so m2 is moving downward and m1 is moving upward. So we have to find the relation between the displacements and the velocities and the acceleration. Now see how to find the relations. So if for example, this is the initial, you say this is the initial line, okay, and after releasing this 2, the 2 is moving downwards and 1 is moving upwards. So if 2 is moving downwards, then this string is also moving downwards. For example, this string is moving x2 direction downwards. Similarly, this mass is moving upwards, so it means that this string is also moving upwards. For example, this string is moving x1 direction upwards. If this string is same, yes, obviously the string is same, it is tied with this mass 1 and mass 2, and it is same. So the distance traveled by these two strings are same. So we can say that x1 is equal to x2. जितना ये नीचे जाएगा उतना ही ये ऊपर जाएगा. The distance that it goes downwards, the same distance it goes upwards. That is why we can say that x1 is equal to x2. Now differentiating this equation with respect to time, we will get the relation between the velocities. Okay, and in the second case also the acceleration part, we can say that if we differentiate this equation with respect to time, we will get the value of accelerations. A1 is equal to A2. So these much relation you have to remember, and the question is like that ki, for example, you will be given V2 and you have to find the value of V1. For example, you will be given x2 and you have to find the value of A2. So first of all derive the relation between x1 and x2, then differentiate it and get it to V1 and V2, and then after that acceleration parts. So this is the case where the same string is there, है ना? So if the blocks are moving the same string, then what will happen? This will happen. Okay, now just complicating these. First, in that case, we will starting the movable pulley. This pulley is fixed. Yes, this is fixed, but this is moving. This can be moving. ये move हो सकती है. Now see, this is the mass B, this is the mass A, and for example, this mass B is moving downwards. So obviously this mass A is moving upwards. Very first, you have to keep an eye on the string, whether the string is same or not. Only one string is there, or more strings are there. Yes, only one string is there. Yes, this is one string. Okay, very good. So see, now if this string B is moving downwards, for example, if this string is B is moving downwards, XB direction downwards, and this one is moving upwards with XA direction, then we can see that that this string is also get down with xb, and also this string is get up with xb. Okay, so here xb plus xb, 2xb is moving. Okay, and here we can see that xa is moving upwards, xa is moving upwards here. So that much xa is moving upwards, it is contributing to xb and xb. So we can say that xa is equal to 2 into xb. That much distance that xa is moving, that is contributed to xb and xb, because the string is inextensible. That is why the length will be same. This length is displaced is equal to this length displaced. So this is the first method. The first method is just taking the relation between the displacements, and then after that you just differentiate this equation. So we will get va is equal to 2vb, and if you differentiate again, then we can say that it is equal to a is equal to 2ab. It is equal to 2ab. Okay, so this is the case. So this is a traditional method. Actually this method is seems like easy in that type of case. For example, in the complex cases, this method is not very useful, because you have to remember that which one is extended by how much and all that. But the second method is very easy. The second method is the method for virtual work method. We will solve this we will just find the relation between the displacements, velocities and acceleration through this method. What the method is saying, we will see. First of all, we all know that the work is the force into displacement, and the displacement and the force must be in same direction. Okay, that is why the work will be positive, है ना? So now the work done for massless body is always equal to 0. This is very important point. See, any massless body, the work done will always equal to 0. Who is massless here? The string is massless here. We assumed from the very first discussion that the string is massless. So the work done by string is 0. Means work done by string you say that to pulling the this mass and this mass, the work done by this string must be 0. Why? Because the string is massless. But why? It is because the work done is equal to force into displacement. So force is equal to mass into acceleration, and if mass is 0, then work done is also equal to 0. That is why this point holds true. Okay, now in the pulley block system, we can say that the total work done by all the tensions, we have studied about the tensions, that the tension will be applying that direction, and the tension will be applying that direction, and this is constant. Here also tension is applying, here is also tension applying, here is also tension applying, here is also tension applying. Okay, this is the same string, but this string is different from these strings. Means this string is tied by another some objects, and this string is tied by only and only B. So here the tension will be applying, and here also the tension will be applying, but T1 tension. So here the relation between the tensions, that T1 is equal to 2T. The first relation is T1 is equal to 2T. This is the relation between the tensions. So now what is the idea of this method? The idea of this method is that the total work done by these tension, all the tensions, just you have to add all the tensions, and the total work done becomes 0. Okay, it means that net sum of all the forces acting on the massless body will be 0. This is the method. Now we will apply this method. How to apply? Now first of all, you have to just see that how many strings are there. There are only 2 strings. First one is this one, and the second one is this one. So first of all, just figure out the tensions. The tension is acting like this here, tension is acting like this, tension is acting like this, that direction, and that direction. Here also the string is different, so tension will be different, so that tension is T1. Okay, so now here the relation between tensions are T1 is equal to 2T. Okay, T1 is equal to 2T. This is the relation between the tension. Now see, if this body is moving in downward direction, for example with VB velocity, and it is moving obviously in upward direction. If this one is downward, then this one will become upward direction. So this is VA. Okay, now see students, now if this is moving with the direction VB, then this block will be moving XB direction downwards, and this block will move XA direction upwards. Okay, now focusing on the block. Okay, focusing on the block, the tension is applying 2T, and the displacement, it is moving XB. The force is applying here at B. The force is applying here. The force is applying here 2T directly. T1 is equal to 2T, and the displacement is XB. Okay, this is the work done. This is the work done for B. Work done by string B. Okay, now at A. Now see the at A. In the A, XA displacement and T is the force. So T is the force and XA is the displacement. So force into displacement means WA is the work done. Now just add all the work done. We have seen that all the work done by the body is equal to 0. The massless string, sorry, the work done by the massless string is equal to 0. So here we can say that WA is T into XA, and plus 2T into XB, it is equal to 0. Now see, T and T gets cancelled, so XA is equal to you say this one becomes minus 2XB. So this is the relation. XA is equal to 2 times XB. Now if we see that the direction, first of all, see here the XB is acting downwards, है so, and VB is also acting downwards, so the work done is positive here at B, but here also the work done is positive, so XA is equal to minus of 2XB is your final relation. Okay, so here we can also say that yes, this is my fault actually, sorry. Yes, see the T is applying upward direction, and XB is applying downward direction. Yes, T is applying upward and XA is also applying upwards. So it means the work done with the T and XA, these both are positive, so WA is positive. See here the T is in upward direction and XB in downward direction. T is in upward direction and XB is in downward direction, so the work done will be negative. So here you say this is minus sign, and if it goes that side, then this one is plus. So XA is 2 into XB. Here is the final relation. Sorry for the mistake. Now see, here also XA is equal to 2XB, and here also the XA is equal to 2XB. I think you have considered that this is the easiest method, but if the pulleys are just is complicated, then this method is very difficult for you. For example, just apply on this pulley. Okay, just solve this question with method 1 and method 2 as well. You will just see the difference between these two methods. You see that this method is easy, I think, है ना? Okay, so this is up to you. So thank you very much, students. Okay.